trying to explain what is meant by Maxwell Boltzmann distribution. In stationary mechanics, in some lectures we already suggested there are different kinds of particles, in which one type of particle, because that's an identical particle, but they can distinguish each other, and we will not deal with the spin of such particle. Such particle can distribute it, and that distribution laws and the rules and regulations of such particle distribution will govern with one type of distribution laws. The law is called Maxwell Boltzmann distribution law. In simply we call MBA distribution, Maxwell Boltzmann. So this is proposed by the Maxwell and Boltzmann. So I will explain today lecture what are the distribution function for this kind of particles. So suppose the particle are, suppose we need to distribute some type of particle. So suppose the particle are distributed in k different energy level, E1, E2, E3 and so on. Ek levels are there. In N1, N2, N3 number of particles are there in each energy level. And I will explain, this is a general way of expression. Here I consider some different type of quantum states also. In pure classically, this type of states are not there. I will come to the end of this session to that point. Let G1, G2, Gk, etc. Gk be the different quantum states associated with energy level. What is this G1, G2? Suppose there are E1 energy levels are there, E2 energy levels are there. With E1 energy, suppose with the same energy there are different states are available. Suppose if this energy, if different states having same energy level, in quantum mechanics is usually we call it as the degeneracy. So actually the G indicate for degeneracy. What is meant by degeneracy? Degeneracy means if the same state, if the more than one or more states having same energy. In that case, so this is a general way of expression, general way of derivation. So here G1, G2, etc. with the different quantum states associated with the energy level E1, E2 and etc. Ek. So we know in this case N1 plus N2 plus etc. Ni will be the total number of particles. Nothing but summation of Ni equal to N. If this is N is equal constant for the particle, total number of particles is always constant. So Dn, the changing total number, I will give the 0. So I will put it as equation number 1. Your N1 E1 plus N2 E2. So if E1, suppose the first energy level E1, with E1 energy there are N1 number of particles. So N1 in E1 plus E2 energy level with the having the E2 energy there are N2 number of particles. So Ni Ei. So this will give total number of energy. Summation over I Ni Ei will give total number of energy. It's also constant for any system. So D is equal to some Ei Dn. So total energy neither be created nor be destroyed. So the total energy is constant. So D is equal to so. Suppose in the last lectures I already explained there is a different way of arrangement the particle in the given distribution. So N1, N2, etc. Ni with k energy level, the way of distribution, the total number of microstates. If in general pure classically it should always equal to n factorial by pi over ni factorial. But here I consider the general way of expression. I consider the degeneracy also. In the last lecture I already explained this one. So the total number of microstates is n factorial product over gi raised to ni by ni factorial. This gi raised to ni will come if the degeneracy will consider. So in this case, for the state which are in equilibrium, in thermodynamic equilibrium means the maximum possible, the most probable states. So for the state which are the equilibrium means the probability of occurrence is maximum. So the total number of equilibrium or thermodynamic probability means the possible microstates, the different way of microstates. So W is a microstate. So W is a microstate. So W is maximum means that system may be in the equilibrium. So W is maximum means log W is as another number is also maximum. So log W is also maximum. I took the derivative of a maximum number. It's a constant maximum number, so its derivative should be 0. So I took differentiating this d of log omega. So d of log omega I can take with respect to ni. So I take dou by dou. I took the partial derivative dou by dou n of n1 of log W into dn1 plus dou by dou n2 into log W into dn2 plus etc. dou by dou nk into log W with dnk. I written it as a summation. The derivative log W is the summation of I1 to k dou by dou ni log W dni. I put it as equation number 3. Y is equal to 0. Derivative log W is equal to 0. So I put it as a 0 and I name it as equation number 3. Here equation 1, equation 2 and equation 3. This is equation 1, this is equation 2, this is equation 3 are very independent to each other. And I am introducing this condition 1 and 2 into the 3 by using a different technique is called Lagrange undetermined multiplication method. And what I am going to do is I multiply one equation with a constant, another equation with another constant, and third equation, and I combine all three equations and I will take this consideration. So here in this one equation, first equation I multiply with minus alpha, as alpha is a constant. Equation 2, this one. Equation number 2 multiplied with minus beta. And adding then this is equation 1 and 2 with equation number 3. Then we have a formula this one. Summation over I equal 1 to over k dou by dou n of log W plus minus alpha into equation 1. This minus alpha into dni and minus beta equation number ei dni is the and took as a constant into dni is equal to 0. Y is equal to 0. I added this equation to here and this is equal to 0. This will be true only when this equation will be true only when the terms in the bracket will be separately become 0. So summation of I equal to 1k dou by dou n of log W minus alpha minus beta e equal to 0. From this equation I can written as log. Okay. So I will put this equation number 4. I need to find what is log W. This is W n factorial. So I need to find log W of this one. Take logarithm of this one. So log n factorial something like a into b. So I took log a plus b. So that is a log n factorial plus product. All over product means while taking the logarithm it becomes a summation. So it becomes summation over I equal to 1 over k. Log a raised to b become b into log a. In that form, this become ni into log gi. Log a by b, log a minus log b. In that way, this becomes minus log ni factorial. Just go through this step once again. You can understand this one. Log w is equal to log n factorial plus product becomes summation over ni is log a raised to b into log ni, log gi minus log ni factorial. Here I am going to apply a Stirling formula. What is Stirling? If suppose if a number n is a very large number and maybe I need to find n factorial. So what I am going to do is I take a log n factorial. Log n factorial is equal to n log n minus n. This formula is called Stirling formula. Log n factorial is equal to n log n minus n. In that way I need to find here log n factorial. So I get n log n minus n using Stirling formula. Here summation is ni log gi. Here also Stirling formula minus ni log ni minus n or minus is this has become plus ni. And log w this one. I substitute this log w in this equation. I substitute this equation to here. Okay, so before that I want to find dou by dou ni of log w. Dou by dou ni of log w. So this is log w. I take log gi. Dou by dou ni. Here n is equal to maximum is a constant. It's not going to. It's not vary. Dou by dou ni become this n is a constant number. So its its derivative becomes 0. So log gi. How to get log gi here? This one log gi dou by dou first into log G here, okay, first into Ni into derivative of log Ga becomes 0 plus log Ga into log Ni, derivative of Ni, so become only log Ga. So please go through this step and you can do this problem. So it's become log Ga from this minus here log Ni plus the first into, what is first? First I took as log x, log Ni into derivative of Ni become 1 plus second into Ni into derivative of log Ni, log x derivative is equal to 1 by x into dN in that form. So is equal to minus this minus log Ni plus Ni by Ni, and derivative of Ni become finally become plus 1. So what is going to happen here? Log Gi here plus 1 will come. This minus is there, so this minus 1 plus 1 is 0 minus log Ni. So this is log Gi minus log Ni. Took a minus outside. What happened? The log A by B form, log Ni by Gi. This is equation number 5. I took this equation number 5 into this equation number 4. What happened? 5 into 4. This is the, instead of this one I put as a minus log Ni by Gi minus alpha minus beta A is equal to 0. I just rearrange this equation. I took this is another side. Log Ni by Gi is equal to minus alpha minus beta A. Here I take anti-log, then become Ni by Gi is equal to e power minus alpha beta A, where Ni is equal to Gi e power minus alpha into e power. This is the total number of particle is the energy in ith energy level, and number of particle in ith energy level with energy Ei. This is the distribution, number of particle distribution in the ith energy level, where I is equal to 1 to over k. We already know. So in another form, Ni is equal to Gi by e power alpha beta A. This equation is called Maxwell Boltzmann energy distribution law. Suppose okay, that's all. So this is a general way of derivation of the Maxwell Boltzmann distribution law. Okay, I think you are following my steps here, and this is a true alternate expression. If the I already know this Gi is just a degeneracy of different quantum states with the same energy level. So with the different states are, if the different states are possibly in the same energy, then this Gi. If Gi is not there, this is only Ni is equal to e power minus alpha into e power minus beta A. So then this becomes 1 by e alpha plus beta A. This is the expression, and I will come to this. So you just go through this one. I need some steps here. Okay. So this is my expression now. The number of molecules, what is Ns, the number of molecules, the number of particles in each cell, the ith cell, as a function of energy is equal to e power minus alpha e power minus beta Ei into Gi. If Gi is there, then this. So this, and if Gi is not there, in another way of expression is equal to e power minus alpha. This also expression if the while the degeneracy is considered, this is the equation. So both are same. So this is one general way of expression. You can find in the textbook both expression the same step. If I start with this one, that is W is equal to n factorial by pi over Ni factorial. If I start with this W, I will end up with this expression. Now here what we have done, we have started with a formula W is equal to n factorial by pi over Ni factorial into Gi raised to Ni. So also product is there, I take a product. So that's all. Pi over I. So I took both are same, that's all. So I will end up with this formula. That is a different. So what is the distribution function here? If suppose if I draw this function, if Ni and Ei is drawing, it's something is come like this. This is the, because e power minus beta Ei, with respect to Ei, this is the exponential decay. So it means what? Lower energy states. Ei is lower, which means lower energy states having the more number of particles. It's having high states contain more number of particles than high energy state. The number of particles is higher energy levels is less. So this is the case. Okay, now here I can add some more terms here. Okay, so Ni is equal to, what I am going to do is, I took a simple expression, that is this one. Ni is equal to e power minus alpha, e power minus beta. In general, e power minus alpha is a constant. Alpha is a constant, so e power minus alpha is another constant. I call it as a. So Ni is equal to a power e power minus beta. This is also an expression form. So I need to find what is a, what is beta. That's our next aim. To find a, what I am going to is, we know summation over Ni is equal to total number of particles. So here Ni is I know. So summation over I, a e power minus beta Ei is equal to n. And I call this as, this a is a constant, so a into summation over I e power minus beta Ei is equal to n. I call this is as a function. I call this partition function. It will partition function, it denotes as z. So need to bother about now what is meant by partition. Just a function like the summation over I power. So this is nothing but a into z is equal to n. So what is n? Sorry, what is a then? A is equal to n by z. So this is a. So I need to find. So now what is expression Ni? Ni can written as n by z into e power minus beta. I got n. There is an unknown constant is beta. I want to find what is meant by beta. So next aim is to find beta. Need to find beta. So how I can find the beta? So to find beta, according to thermodynamics, we know. According to thermodynamics, we know energy in terms of or dq, or usually it's called du or de, both the same. From second law of thermodynamics, we have an expression T ds. Here we have an expression for dx is equal to de by t. I put this equation, some equation. Previously I will end up with the equations. So I call it as a 1. Just check what this equation, actual equation number. And from this thermodynamic statistical mechanics, we have an expression for di is the summation over I Ei into dni. And we already know there is a connection between thermodynamics at start with Maxwell entropy relation, that is K log W. I took a ds is here. What is K is a constant. So d of log W, and what is d of log W then? And here also, what is W I took? I took as a W as n factorial by product of ni factorial. In simple way, both way we can find here, and took a log w here. What is log w? Log n factorial minus summation over I log ni factorial. Log ni factorial. This can represent as n log n minus n minus summation over I ni log ni minus plus ni. That's the summation is the, and log w is this much, and here we can write as n log n okay. So what happened here, k into derivative of log ni. So I need to find the derivative of this one. So derivative of log w is this much. Here n is a constant number, its derivative becomes 0. So this term is not need to consider. All are constant number. For varying things ni is there. So if I take derivative of log ni, first term here, ni into derivative of log ni plus log ni into derivative of ni, product rule I need to apply, then derivative of ni. This is n. So this minus is coming here, then it's become ni into derivative of log ni plus that plus minus become log ni into dni plus dni, this derivative of this one. So what happens in this case? This case minus k into ni derivative of log ni into 1 by ni into dni. So ni cancel, ni into 1 by ni into dni minus log ni into dni plus dni. So this ni will cancel here. Ni is here, 1 dni is minus dni is minus dni. This is a plus dni will cancel. The remaining term is minus k log n dn. Please check the whole step. Please check whether I made mistake or not. So what is happening here? So this is the ds. Okay. Now I have a summation here somewhere. Should have a summation over here, and this become minus k summation over I ni we know. What is ni? A power e power minus beta e, where ni is equal to a power e power minus beta ei. I substitute here this one, so it becomes summation over I log a minus beta ei into dni. So this is case, and take a ds here. Here ds is equal to minus k as a constant, so log a to outside summation over I dni plus minus k beta ei dA. Summation over beta summation over I k beta ei dA. So here summation over I dni, we know already summation over I dni is equal to summation over I ni become total n, so derivative becomes 0, and here the summation over I ei dni, so it's become ei dni is nothing but dE is dE. So what happened is ds, then ds is equal to k beta dA. So I have an equation now here. Here previously equation number, now I put this 2. Here I have a ds, here I have another ds. I compare these two equations 1 and 2. What has happened? Here ds is equal to k beta dI. So this, comparing these two equations, I get k beta is equal to 1 by t. So beta is equal to 1 by kt. So this is the value for expression for so second thing. So now I got two constants a and beta. So what is ni now? This ni can written as n by z e power beta is 1 by kt, so it's nothing but minus e by kt. So I have got both constant a and beta. So this is the Maxwell Boltzmann distribution law. This is the expression, and I think you are following this. All of you are following. Okay, now suppose what is the probability of a particle in a energy level di. So I need to suppose the probability of a molecule to possess energy level ei if the possible the number of states in ni and total number of particles is n. So in that way, this ni is nothing but e power minus ei by kt and n. This is where we can express the total number of probability, and also in general there is a distribution function f of ei. So total the distribution function can be denoted as f of ei, that is denoted as ni by gi. In that way, the distribution function ni by gi is considered as f of ei, so is equal to e power minus alpha e power minus ei by. So it's e power minus alpha. If you want, you can call as a minus, where a is nothing but n by z. So this is the different form of Maxwell Boltzmann distribution law. What we are trying to do here is the total number of molecules in a cell with each cell as a function of energy associated with that particle in the cell is nothing but ni is equal to n by z e power minus beta ei. Minus beta is equal to 1 by kt, so ei by kt. This is the one way. If we consider if you have one energy level has different state, that is we call degeneracy. If we consider degeneracy, we can call is equal to gi into, that is n by z into gi e power minus ei by kt. So this way we can find the Maxwell Boltzmann distribution, the different possible distribution. We started with W, W means n factorial by summation over I ni factorial. Or if you consider this as a degeneracy, we started with n factorial by product of gi raised to ni by ni factorial. So I think you already all of your